Lambda expression part 1. So here we are going to learn what is lambda and why we want to use lambda expression. By the way, we are going to use these two terms interchangeably, lambda expression or simply lambda. And we're going to see how lambda is implemented in Java 8. And we are going to see the concept of functional interface. And then we're going to learn the syntax of lambda expression in Java. And then we're going to learn the concept of method references. So we have a lot to learn in this presentation. So what is and why lambda expression? Lambda expression is a mathematical, basically, concept. It's a formal system for expressing computational behavior, or we say parameterizing behavior through function or function object. So I'm using the term function object as explicitly as possible because now using lambda, function is a genuine object, okay? So in a sense, function objects are first-class citizens, just like a string object or person objects are first-class object. What that means is that function object can be assigned to a variable, and function object can be passed around as a method argument, and function object can be returned as a return value, just like a string object or person object can be assigned to a variable or can be passed around as a method argument or can be returned as a return value. So pretty much all modern programming languages support the lambda expression. JavaScript, Lisp, Scheme, Ruby, Scala, Clojure. Pretty much all modern programming languages support the lambda expression. And Java was a little bit behind the curve. And finally, it supports lambda with Java 8. And that is a good thing. Okay? In fact, lambda is considered as the biggest language change since genetics of Java SE5. So why you want to use lambda? Basically, by using lambda, it lets you write your code by declaring what to do rather than how to do it. So your code is going to be a lot simpler, and it's going to be a lot more concise, and it's going to be more expressive. What that means is it's more English-like programs rather than very cryptic coding. Which means it will result in high productivity and highly flexible and fluent style programming is now possible with lambda. Okay? And we're going to see all these examples moving forward. It also promotes immutability. So basically, because there is really, you can write your code in a way, in a functional programming style in which you do not really maintain any state. So that means there is a less concurrency issues. Okay, because there is no state to be maintained. It enables parallel programming and lazy evaluation, and which result in higher performance. You can actually have multiple thread running on in maybe different cores. So that is in fact possible using lambda. Before lambda, basically you have to use all these very complex multi-threading APIs in Java, like a fork and things like that, which is very complex and error prone, and so it's not good. But by using lambda, only thing you have to do is creating a parallel stream and everything is taken care of. So it will actually result in a lot simpler parallel programming, and of course it will result in higher performance. Lazy evaluation, we're going to actually talk about the concept of it later on. Basically, your programs could be analyzed to find, the compiler will actually analyze what is the best way to execute your code. Okay, so we're going to actually talk about that using an example later on. Lambda forms a basis of functional programming paradigm. So functional programming, in fact, is becoming very popular, especially in parallel computing and the big data operating environment, because the core of functional programming is that you do not have to maintain a state. Okay? So, by having a lambda, meaning by having function object to be behaving as like a regular object, now you could actually write a functional programming code using Java. It basically results in richer collection APIs possible. In fact, example of that is a stream API, which is very, very concise, expressive, and simple, highly performing APIs that you can use. It also allows adding the new methods to existing code, such as iterable, list, and map. If you take a look at these APIs, they actually provide more method that takes actually the Lambda expression as an argument. Okay, so that is the benefit of using Lambda. Now let's see how we can actually use Lambda in Java 8. So Lambda concept versus implementation. So as I said before, Lambda is mathematical concept that has been around from 1930 or 1929. So, it has been around. The concept has been around many, many years. So different programming languages have different implementations of Lambda expression. So you as a Java developer need to know the concept of Lambda expression, and you also need to learn how Java 8 implemented Lambda expression. Okay, so in Java, Lambda expression is implemented essentially as an anonymous function. Okay, so in fact, Lambda expression is considered as an instance of a functional interface. By the way, the definition of a functional interface is an interface with a single abstract method. Okay, in fact, the type of Lambda expression is indeed the type of that functional interface. Okay, so let me repeat. We're gonna talk about the concept of functional interface in detail in the following slide. But for now, you can think of functional interface is just a Java interface that contains a single method. Okay, so Lambda expression is considered an instance of that functional interface. So it is basically implementation of the single method of that interface. There is really no native function type like in JavaScript in Java 8. This is deliberate decision by Java 8 Lambda designers, mainly to have backward compatibility. Okay? The usage areas of Lambda in Java applications or programs: replacement of anonymous inner class. You can actually see that example in the following slide. Error handling, iteration of a list, parallel processing of collection elements at the API level, functional programming and streams. So basically, any place that you need some kind of a functional behavior, you could use Lambda. Okay, all right. Too many abstracted description of Lambda. We're going to see example of this in the following slide pretty soon. So what is functional interface? So as I said, functional interface is a regular Java interface with single abstract method. So, even before Java 8, there are examples of Java interfaces that contains a single abstract method, and they are considered as a genuine functional interface. Okay, so it's very common in Java programs. Sometimes this functional interface is called a single abstract method. I mean, single abstract method is called the single abstract. Yeah, okay, functional interface sometimes called a single abstract method. Okay. So just like any other Java interface, it can be used as a reference type. So what that means is that your function interface type could be a variable type, or it could be a type of an argument. So this is an example where we are providing the Lambda expression on the right. Yeah, we're going to actually talk about this syntax later on. On the right of the equal sign, this is a Lambda expression. We are assigning Lambda expression to the type of my functional interface. So the point is that the functional interface is a genuine type, okay? Which means it could be used as a type of a variable, or you could pass it, the type of it, as a method argument, or you could actually return it as a return value. Okay, even though it is Java interface, it represents the function. So if you take a look at the example of Lambda expression on the right of this here, basically we are taking the arguments and then the arrow and then body of the code. So basically Lambda expression is in the form of set of arguments and code block. And we're going to see syntax of it in a few minutes in a bit more detail. Okay, so as I said, functional interface is an interface, a regular interface with a single abstract method, right? Okay, so in fact, we have these functional interfaces even before Java 8. So Java 7 and below versions have several functional interfaces already. For example, runnable. if you take a look at the runnable interface, it does have a single abstract method of run, right? Same thing for action listener interface. It does have a single abstract method of action performed. And comparator is, again, has a single abstract method of compare. By the way, there is also another method. If you take a look at the source code of comparator, it does have another method called equals. So in this case, this is not considered as an abstract method because this is in fact the from the object class, right? Okay, so comparator is considered as an interface that contains a single abstract method. So these are all examples of functional interface. Okay, so any interface with a single method is considered as a functional interface in Java 8. So runnable, action listener, and comparator, they are all considered as a genuine functional interface in Java 8. Okay, so Java 8 Lambda works with all libraries that use functional interfaces without any need to recompile or modify them. So your Java 8 code that uses Lambda should work with any Java 7 and below libraries. Okay, so there is no backward compatibility issue. Okay. Java 8 also introduces functional interface annotation. Basically, this is provided as a way for you to use to detect a functional interface is not violating the requirement of functional interface, meaning if you have two methods in the functional interface, and if you're using this annotation, compiler will detect it. So when this functional interface annotation is used, Java 8 compiler produces an error if interface has more than one method. So this is a compile time utility annotation, meaning it is a helper annotation for the compile time for the compiler. In the same way, we are using override annotation to find out if a method is in fact overriding or not, right? So override annotation is used at the compile time to detect a problem, right? Same thing, functional interface annotation is used to detect whether a particular interface is in fact functional interface or not. So this guy, the first example here, this is fine. There is no compile error because my interface is only a single method. However, here, if I add two methods, my method and my method 2, then you say function interface annotation, compiler will say, this is not a function interface because you have a two method. Okay, so function interface is used to detect the syntax of function interface at the compile time, meaning it should have a single method. Okay, all right. Okay, so where to use Lambda expression in Java application? The concept is basically, again, you can use Lambda expression any place a functional behavior is required. Okay, so this is a little bit too broad description. We're going to see a lot of examples, okay, later on. So Java applications, you can use Lambda expression in any place where functional interface type is expected. So in Java, when you're using function interface, basically you are actually specifying a behavior that is behavior that is actually represented by a single abstract method of that function interface. Okay, so you can assign Lambda expression to a variable whose type is a function interface. You can pass Lambda expression to a method as an argument whose type is, again, functional interface. Okay, yeah, I know some of you probably got lost by this time because I just talked about the concept too much. But don't worry about it. We're going to actually use examples moving forward in a few minutes. So let's take a look at an example of Lambda expression. So let's say we have a functional interface called calculator. Okay, and this should not cause any compile time error because calculator interface as a single method. Okay. Now, we should be able to assign the behavior. So, by the way, in Java, the behavior is basically set of arguments and code block. So here, the behavior is multiplication of this x and y argument. So we can assign the actual behavior to multiply function interface type And same thing to, in this case, divide. So you can see this function interface could be used as a reference type, in this case, a type of variable of multiply and divide, right? So once you got this multiply and divide variable, whose types are this function interface, then we can call that method of calculate, passing the actual value of x and y. So in this case, we should be able to call calculate method passing 50 and 10, and it should return 500. Same thing for divide, it should return 5. Okay, so the key point in this case is that these multiply and divide variables are now containing behavior. That behavior is represented by this lambda expression. So again, we're going to talk about the syntax of lambda expression later on in detail. But for now, you can think of this behavior as set of arguments and the body of code, block of code. In this case, block of code is pretty simple: multiplication of x times y and dividing x by y. That is the code block. Okay. Okay, so that is a case that where we are actually assigning the functional behavior into a variable of multiply and divide. So this is an example where, in fact, the functional object is a genuine object. We are just using multiply and divide just like an object. Okay. We can pass this functional behavior as an argument. So suppose if you have, again, calculator function interface, this is the same as before, right? Now we have a method. So we have a method called the my method. It could receive calculator function interface as an argument. Okay? So internally, it's actually calling calculate method of that function interface. Okay? Now here, let's take a look at how we can pass the functional behavior to a method. So here we are passing the behavior to this calculator type of my method. So this one should work just fine. You're passing behavior to a method as an argument. Does this make sense? Okay, all right. Finally, we have an exercise 1. Okay, so just like what you have done in previous case, you're gonna just unzip the zip file, and we have a bunch of lab exercises. Okay, so here you can certainly take a look at the lab documentation. So labs and part 1 index HTML file. So you should be able to see the lab documentation. So exercise 1 is function interface. Okay, so we're going to take a look at the Lambda function interface. Okay, so that's basically this code. We have a function interface, and we have a calculator, and then we are going to create multiply and divide variables. So these are exactly the same code that I actually mentioned to you using the slide. Okay, so when you run the code, it should actually work as expected. And then function interface, if you try to add another method, then it's going to actually cause a compile error. And then you're going to actually do your own exercise. So let's actually do that. So this is the Lambda and the function interface, this project. So just take a look at the code. So we have a main. Okay, so when you run the code, and it should actually display the result. Okay, and then calculator is function interface. So if you try to add another method, int maybe void, say void hello, something like that, then it's gonna have a compile error. Okay, so it says invalid function interface annotation. If you remove this guy, then it's just a regular interface, right? So compiler will not complain about it, but as soon as you have function interface, it will compile, it will say, you cannot have more than one single method. Okay, so you can just delete this guy, then it should work fine. Now here, you can take a look at this code. Okay, so here, so this is exactly the same code. Okay, so this is a case that we are assigning this functional behavior to variable. Okay, this is a case that we are passing this multiply and divide object to the sum method, or you can directly pass the lambda expression. Okay, so for your own exercise, create another function interface called the my greeting interface. Okay, with this single method. all it does is basically say hello. It doesn't return anything. Okay, I probably have a printf, a println statement, and then set a variable of my greeting interface type of my var with some lambda expression. So use this guy. Since you haven't learned the syntax of it, you're gonna just use this guy, and then you can actually call the say hello method with my var, and result is supposed to be something like this. Okay, since this is the first exercise of lambda expression, so let me actually demonstrate this guy, and then you're gonna just follow exactly what I did. Okay. All right, so here we're gonna create the my greeting interface. So let's create the new class, and we're gonna say my greeting interface, and we want to make sure that this is a function interface, so we're going to use the functional interface annotation. Now it has to have a single method, right? So it should have say hello method, so public and the void say hello method. Maybe it will take some kind of a name, okay, and we'll say return. Oh, this is just void, so we're going to just use sysout, and we're going to just display name or something like that. Okay. Oh, this is interface. I cannot actually do this. Yeah, my mistake. Sorry about that. So it should be interface, right? And I should actually just have a single method. So the public void and say hello, and it will take a string and name, and that should be it. Okay, so we define a function interface of my greeting interface, right? Okay, and now the next thing we want to do is set a variable of my greeting interface type of my var. So here we're gonna say my var. Yeah, so the type of it is my greeting interface, right? So my greeting interface var, my var. You can actually name it any way you want. Okay. And then we are going to provide lambda expression. So lambda expression is, this is the argument, and then what we're going to do is we're going to just print things out. Okay, so I'm going to just copy this code right here. Okay, like this, right? And then we are going to create, then we're going to actually call this guy. Okay, so we should be able to my var, so my var, and dot. We're gonna actually call the say hello method, and you're gonna provide some name, Sang, right? Okay, and like this. Okay, and then when we run it, it should actually display hello Sang. Okay, all right. So that is pretty much it. I'll give you a few minutes to try this exercise. Okay, so anonymous inner classes replaced by Lambda. So given that typical usage of anonymous inner class is an example where argument whose type is a function interface, you can now replace it with a Lambda expression. So if you think about it, in pre-Java SE programs, anonymous inner class has been used as a kludge solution for passing functional behavior, right? If you think about it, okay. It is a kludge, but it lets you, in fact, pass the functional behavior. Now, that functional behavior could be, that code, that complex code could be rewritten using Lambda, okay? So the current code, what uses anonymous inner class, can be simplified through the usage of Lambda. Basically, all you have to do is to take the arguments and code block with the following Lambda syntax and removing everything else. So let's see an example of it. So this is a case that we are using runnable, okay, the interface. So runnable is one of those examples that has a single method, right? So this is how we are in fact using anonymous inner class of runnable interface. So we basically create a behavior of this run, right? Okay. So because runnable is a function interface, we could actually replace this code using Lambda. So in order to use Lambda, basically all you have to do is just taking the argument. In this case, there is no argument, right? So basically it's going to be just parenthesis and the body of the code block. So the red colored portion of this, the implementation of anonymous runnable interface can be just extracted as code block, and this is how you can actually replace it with a Lambda. Does this make sense? Just take the argument and code block. Okay. All right. So this is how you do it, and the reason it works is because the compiler knows what is in fact the type of single method interface of runnable, right? When compiler take a look at the runnable, it has a single method. That single method will be applied with this code. Okay. This is action listener. So we have a test button that receive action listener object. Again, this is the anonymous inner class, and again we are going to take just the argument, in this case event, okay, and then code block. You don't have to specify this type because compiler already knows the type of this argument from the function interface, right? So you just take the argument and then you are providing code block. So this is another example where we are replacing anonymous inner class implementation with Lambda. So again, here we are using Lambda wherever a functional behavior is expected. In this case, we are using anonymous inner class to provide some kind of functional behavior, right? This is comparator example. So when you are calling sort method of collections utility class, you provide a collection object, in this case person list, and then you are providing anonymous inner class implementation of comparator, okay? And here, basically, again, the set of argument is two object, person 1 and person 2, and the code block is this guy. So, in this case, you don't really have to have a return statement because it's a single the expression. So basically, you are just taking these two arguments, and you don't have to have this person type, the argument type. You can just say P1 and comma P2, and then provide a code block. Okay. All right. So that is the exercise 2. So here we are rewriting the anonymous inner class implementation with a Lambda expression. Okay. So let's take a look at let's take a look at the runnable case first. Okay, so here we take a look at the main.java. So here we are using anonymous runnable. That's the anonymous runnable inner class, and here we are using Lambda. So basically, you are just taking this argument and code block. Okay, and both of them should work fine. So I'm gonna just run it, and it should actually return some values. Okay, so for your exercise, create another set of anonymous runnable and Lambda runnables, and when run, display the current date and time. Okay, pretty straightforward. And the next one is action listener case. So we have action listener case. So here we have two buttons. Okay, J button 1, test button 1, and test button 2. And this is an example where we are using the anonymous inner class, and this is an example where using Lambda expression. Okay, so when you run it, so let's just run it. When you run it, you're going to have this the code. So this is a case that when we click anonymous action listener, it will just display something, right? Same thing for the the Lambda expression should work exactly the same. Okay, all right. So for your exercise, create another set of buttons, and the one using anonymous action listener and the other using Lambda action listener. When clicked, each button should display current date and time. Okay, so pretty straightforward. The last one is comparator. So comparator. So here we have sort method of collection object is being invoked, and this is a person list. So person list is we have a test data. So person list. Let's see, person. Yeah. So create short list. We have test code that actually creating bunch of the person. So this person list is already created. Okay, and then we are using anonymous inner class of comparator of person type, and basically we provide the behavior of this method, right? Okay, so and then we just display the person using this for loop, and then we are going to replace this code using Lambda. So basically this stays the same, but this is going to be code block. So we basically take this argument, person 1 and person 2. By the way, as you're going to actually see later on, you don't have to have this type because that's already known to the compiler. Okay. And then basically we are just capturing this logic and provide right here. So that's basically how it does. We can actually provide the descending order by just actually changing P1, P2, but just replacing P2 and P1. Okay. All right. So for your exercise, create a list of integers, sort them using anonymous inner class of comparator, and then sort them using Lambda comparator. Okay. All right, so I'm going to give you guys about 10 minutes to do this exercise. Okay, so we have seen examples of Lambda expression, but we haven't really learned the syntax of it. So this is the time we're going to learn the syntax of it. So general syntax of Lambda expression is argument list and code block. Okay. Now this syntax could be simplified in several ways. First, type inferencing for the arguments, and then you could omit parentheses for a single argument. And when the body has only a single expression, then there is no need to specify return, no need to use semicolon, and no need to use curly braces. Okay, so let's see each of these simplification in a bit more detail in the following slide. So this is a case where type is in fact inferenced by the compiler for the arguments. Java compiler already knows the types of these arguments from the single method signature of the function interface. Okay, so you don't really have to specify the type of these arguments. So instead of specifying the type of myArg1 and myArg2, you can just simply provide the names of arguments, and that should be good enough. Okay, because compiler will infer the types of these arguments from the function interface's method signature. Now, single argument with no parentheses. If there is a single argument, then you don't have to specify parentheses. You could if you want to. Okay, so instead of myArg1 with a parenthesis, you can have just myArg1, and that should be good enough. Okay. Okay, now when the body has only a single expression, then you don't have to specify the return statement because expression will be evaluated and the value of the result of that evaluation will be returned automatically. And you don't have to use you don't have to actually have a semicolon at the end of that expression. And you don't have to enclose the expression with curly braces. So in this example, if I have a single expression, you can certainly do return, and you can certainly have semicolon at the end. You can certainly have a braces, but none of those are in fact required. You can just specify set of arguments, and then you can just have that expression. Okay? So let's see examples of this. So the first example is here we are receiving int x and int y as arguments, and then the body of the code is return x plus y, semicolon, and curly braces. Now we're going to actually do depend on type inferencing on the compiler, so you don't have to specify the type of argument. So we're going to actually have just x and y. Then, because there is a single expression of x plus y, we can just remove this curly brace. We don't have to have a return statement. We don't have to have a semicolon at the end. So the next simplification. Now, if there is only a single argument, then you don't even have to have the parentheses. Okay, so this is the simplification. This is another example. So if you have receiving anything, by the way, if you're not receiving anything, any argument, then you have to have a parenthesis. In the example in the system.out.println. And because it's a single expression, you can just say system.out.println, and then you provide a value. And there is no semicolon at the end, there is no return statement, and there is no curly brace. Okay. However, if there are multiple statements, then you have to have a curly brace, and each statement ends with a semicolon, right? And then the last statement should have a return statement. Okay? Does this make sense? Any questions on this slide? Okay, all right, so let me just... Okay, so the next one is lab 3. So in this case, we are just exercising the syntax. So here, lambda syntax 01, lambda syntax 02, lambda syntax 03. Those are the exercises I want you to do. So let's take a look at the main here, the main code. Okay, so here we are setting the variables. Okay, so this is the lambda expression. And then we are simplifying it with just using x comma y because we don't need to specify the type, okay, of the arguments. And here so here we are still using the same code here, right? And then we can actually use it. So the Dylan, I mean, you know, you cannot actually call a calculator like this, right? Yeah, you have to actually use a variable of the types, in this case, multiplier. Okay, right? You know, remember this is an, you know, the this is a variable that actually you know, containing functional behavior. Okay, so pass lambda expression as an argument, and this is a case that we are passing again the you know, instead of doing this, we could actually pass like x comma y. Okay. Okay, so for your exercise, add and subtract calculator type object and invoke them using some numbers. Again, you know, I want you to use as simple as possible syntax. Okay, all right. So that is the syntax 01. So this is a case that we are, you know, depending on the compiler to inference type argument. The next one is the next one here. Here now. This is the when there is a simple expression. So when there is a simple expression, we can just do this. Okay. So here, instead of doing this, you could actually do x times y or something like. So this is a divide. You know, that's using the single expression body. Okay. And the rest of the code is the same thing. So instead of this is the more verbose way of actually doing things. Instead, you can just do this. Okay. Again, do add and subtract calculator type object, invoke them using some numbers, and again, you're trying to use as simple syntax as possible. The last one is, let's see here. So here, we have calculator. So the, and yeah, calculator, multiply and divide. So pretty much the same thing. And yeah, so this is a case that we are actually having square. So this is a case that where we have single arguments. So instead of actually having a parenthesis, you can just pass this guy. Okay. All right. Yeah. So these are relatively straightforward exercises. So as long as you do, you know, the one of the exercises in 1 or 1 or 2 or 3, that should be good enough. I'll give you a few minutes to the syntax of syntax exercises. Okay, and we'll move on. Next big topic is what is called method references. Okay, so what is a method reference? Method reference is a little bit of simplified syntax. It's a compact and more readable form of Lambda expression for already existing method. So it's going to use the notation of colon operator, okay, as a way of using method reference. The method signature and arguments and their types of the existing method must match with the one of the function interface. So the existing method has to have matching method signature with the method in the function interface. Otherwise, you know, you cannot use this method reference. So let's see an example. So let's say we have Lambda expression right here. So we have my function interface, and the name of the variable is myObject2. And it's receiving name and age arguments. And then basically, we could actually invoke existing method of my class, which is taking name and age. Okay. So then we could call my single abstract method of my object2, which is the name of the method in the my function interface, passing this to argument. Suppose if you have, so in this case, we verify that is in fact the my existing static method is a way of, basically this is an example, just indicating that my class has my existing static method that takes this name and age. So if you take a look at the function interface of my function interface, the single, the abstract method should in fact receive this name and age parameter in the same way. So in that case, we could actually use my class : existing static method. So this is the same thing as this. So as you can see, method reference is more readable, and it's a bit more simpler because you don't have to specify the arguments, okay, and you don't have to specify the parameter arguments. You don't have to specify arguments, and you don't have to specify this arrow sign, okay. So this is a bit more simplified. Okay? So we're going to take a look at the, in fact, different types of method references, and then we're going to do some exercises, and you will have a better understanding. So there are 4 different types of method references. The first one is you can make a reference to a static method. So it's going to be in the form of class name : static method of class name. Okay, and of course that static method should have the same method signature with the method of the function interface. You could also have a constructor reference, or a reference to a constructor. So it could be class name : new, and then you can specify the notation like this. Okay. You could also have a reference to an instance method of a particular object. So in this case, my object is an object instance of maybe my class, and then this is instance method, my instance method. Okay. The last one is what is called the reference to instance method of an arbitrary object of a particular type, and basically it's the name of the containing type and instance method. So this is a little bit more complex. So I'm gonna explain the next, the 4th one later in a different section. So we're gonna mostly focus on the first 3, okay, because they are more easier to understand. So let's see example of each of these reference method reference types. So this is a first case. It's a reference to static method. Okay. So let's say we have my function interface that contains a single method called my single abstract method, and it's receiving name and age. And name is string type, and age is int type. Now suppose if you have existing method in some class, so I have a my class, and it has existing method called the existing static method, which contains exactly the same method signature, meaning it should have the same set of arguments, and the types of those arguments are matching. Okay, in that case, instead of doing this, so name and age, and I could say my class.existing static method name and age, I could just simply say my class : existing static method. So this is a simplified way of specifying your Lambda expression. Okay, does this make sense? So when the compiler actually see this code, my class : existing static method, it will take a look at the existing method of the class and see whether in fact it contains the same method signature of the function interface. As long as they have the same the method signature, meaning same set of arguments, same number of arguments, and the types of those arguments are the same, then it should be able to actually use this code, in this case, this body of the block as way of the body of the Lambda expression. Okay, does this make sense? All right, so let's actually do the exercise before we move on to the next one. So if you take a look at the method reference, and the one that I want you to take a look at is the method reference, the static method. Okay, so this we have in fact the multiple cases. Lambda, Lambda method reference static method. So let's take a look at the first simple case. So let's take a look at, so here we have, So this is the anonymous inner case example. So we have my function interface, and then we are just providing implementation, and then my existing, my existing static method. Okay, and now we can actually, rewrite this code using Lambda expression. So only thing we have to do is basically argument. We don't have any argument here, and then body of code. So that is a Lambda expression. Okay. And then we can just call that method, and this is a method reference. Okay, so because existing method of the my class has the same method signature of this guy, because in this case, they have a same method signature because there is no argument, right? I should be able to call my class existing method. Okay, so for your exercise, create another static method called my existing static method in my class, and which prints out today's date, and invoke this method 3 different ways: anonymous inner class, Lambda expression, and method reference as shown above. Okay, does this make sense? I mean, you guys want me to demonstrate this one, or you can just handle this one yourself? Anybody? Any opinion? Okay, so I'm gonna actually explain. I'm gonna explain a couple more. Okay, so Roma says yes, please. So I'm gonna just demonstrate this guy. All right. So create another static method. So I'm gonna create another static method called my existing static method in the in this case my class, right? So I'm gonna go to my class, and I'm gonna create another existing method. So it's gonna be public static my existing method. Yeah, it could be void, and then like this, and let's see what it says. Method which prints out today's date. Oh, okay, so it's pretty straightforward. So you can actually just sys out and new date like this. Okay, and then import the date class. Okay, so we have a static method just display the new date. Okay, and what we want to do is invoke this method 3 different ways. So let's actually try to use the anonymous inner class. So I'm gonna just copy this guy, and move this guy. Yeah, I'm gonna just actually do it right here. Okay, and here my object 2, and then my function interface, and the method is my single. Yeah, so this one is this one has to be the same interface, and then this one I'm gonna just change it to my existing static method, right? Okay, like this, and we are gonna call it my object 2. Okay. Actually, I'm going to use the my object 2 because I have a my object 2 here. Okay, so 2. Okay, so let's actually run this guy. Yeah, so it's actually displaying the date. Okay, so we just use the anonymous inner class. Okay, and typically that's not what you want to do. Instead, I want to use a Lambda expression. So I'm going to actually use a Lambda expression. So here, again, I'm going to so let me just write just for the sake of showing you guys my function interface, my object 23 or something like that, and then it's gonna be my class and static method of my existing method like this. Okay, and then I'm going to call my object 23, and then the method is my single abstract method like this, right? Okay, so now this time we're gonna actually have 2 instances of the date. Okay, all right, so let's just run F11, and you should have, in fact, yeah, so this is the second one, which is the case we are using a Lambda expression. Now, because my existing static method and my function interface, if you take a look at the my function interface, it does have, in fact, the a single method, and the method signature matches because there is nothing to match. In fact, it's an empty argument, right? So they should match, right? So now we're gonna actually use the method reference. So this is the case we are using method reference. Okay, So here it should be the same type, my function interface, my object 34, and then here I should be able to use my class colon, and this time is going to be my existing method like this, okay? And then again I should be able to call my object 34, and the method is again my single method, okay? So this time we should be able to actually see the data object in 3 different occasions. Oops, JVM dump, what the hell is this? Okay, so why complains about this? This one, they all actually displayed correctly. And then I got some kind of J dump, unable to get J and I 1.2. Yeah, so I have no idea why that is actually happening, to tell you the truth. So yeah, it actually all displayed fine. Let me actually just kind of see whether I'm going to just have all these guys commented out, see whether we are still having that problem. Okay, and let's run it. Okay, that works fine. So it looks like there is some kind of conflict with, the reason is because, you know what? This is the problem. Yeah, so you know what? We have, in fact, if you take a look at the my class, we have in fact the 2 static method, existing static method and my existing static method. So when you're using method reference, it doesn't know which one to use. So that is a problem. So it might not be in fact the perfect exercise. Okay. All right. So anyway, so you guys get the idea. So that is a simple case. So this is a case where we have a method signature doesn't take any argument. So now let's take a look at the next case. So that is the method O2 variable. So let's take a look at the main Java here. So this is the case that we have a method that takes the 2 arguments, name and age. Okay. So if you take a look at my function interface, we have a my single abstract method. So instead of actually no arguments, as we have seen in the previous case, it's taking name and age. Okay. So we should, if you're using the method reference, static method of the, static method reference, then the class, my class in this case, should have the method that takes this same method signature. So yeah, so this is an example. You can see we have a 2 static method. One is actually using 2 arguments. The other one is using a single argument. So compiler knows exactly which one to use. In our previous case, we have in fact the 2 static method that doesn't take any argument. So that's the reason it has some kind of complaint, some problem. But here, this existing static method and this existing static method, they have a 2 different signature, method signature, meaning 2 different the set of the arguments. So it will actually use this guy. If you take a look at the function interface, it does take these 2 arguments. So there is no confusion in terms of which static method in the my class is going to use. Okay, so if you take a look at the main.java here, again, this is a case that we are using anonymous in a class. Okay, and this is a case we are using Lambda expression. This is a case that we are using method reference. Okay. So now if you're actually trying to use this, the single abstract method Tom, it's going to be a compile error, right? The reason is because there is no, in this case, there is no existing, basically my single abstract method, okay? The function interface of this guy, there is no method that actually match that guy. All right, so that's the reason you're going to actually experience a compile error for this guy. So you have to actually pass exactly the same set of arguments and same types of that argument according to the function interface. Okay. All right. So I'm going to just comment that guy. So for your exercise, create another overloaded static method called my existing static method, which take the name and hobby. Okay. So both arguments are in fact the string type, right? Which would print out something like hello Sang, your hobby is golf, right? Create another function interface called the my function interface 2, whose abstract method takes the name and hobby as arguments, and create object of my function interface 2 type in 3 different ways: anonymous in a class, Lambda expression, and method reference, and invoke those methods using whatever test data of your choice. Okay. So if you want, you can just skip the exercise of 0, 1 simple and instead actually just do a variable. Okay. The last one is argument. You know what? Yeah, so let me explain this case as well. Then I'm going to actually let you do the exercise of maybe 2 first, and then if you have time, do the O3, and then I'm going to actually, I'm going to actually explain the rest of it as well. Okay. I don't want to spend too much time explaining this exercise before you get your hands on it. So let me actually explain this case. So this is a case that we are using function interface as a method argument. Okay. So exactly the same kind of code here, name and age, but in this case, we have, your method. Actually, we have your method, which is actually receiving this lambda expression as an argument. Okay. All right. And so this is the lambda expression, and this is the lambda expression using static method. So, I'm just using static method of that class. So that's perfectly fine. Okay. And then I'm going to just use a method reference. So I can say my class : existing static method. So for your exercise, create another method called the your method 2, which is receiving my function interface 2 type, and pass the lambda and method reference to my function 2. You create, something that you create in the previous step, and then just, call your method 2 method. Okay, so I'm going to let you do exercise 2 and 3. So skip the O1 and do 2 and 3, and then I'm going to actually come back and explain some of the more example code, and then we'll move on.